Take some quick notes for Unit 2, Day 1. Right below this on your notes, Unit 2, Day 1, if you would go ahead and write your learning objective. Today we're going to classify polynomials according to their number of terms and degree. If you'll start up in the top left-hand corner of your notes where it says number of terms, copy down these 4 terms: monomial, binomial, trinomial, and polynomial. The prefix mono means one, so monomial just is talking about one term. If we have a polynomial that only has one term, you will have no pluses or subtractions. For a binomial, think like bicycle, you're going to talk about 2 terms here. Okay. For a trinomial, we'll think tricycle, you're going to have 3 terms. After 3 terms, we just say that we have a polynomial, something that has many terms. So greater than 3, we just call a polynomial. On all of these, the binomial, the trinomial, and or the polynomial, you're going to see pluses and minuses. Okay? Let's do a couple of examples. Take a moment to copy down these 3 problems. In the first example, you can see here that there's a plus in the problem that separates the 2x squared and the 3x. That means we have 2 terms here. If we have 2 terms, then we have a binomial. In the second example, you can see that there are no pluses or minuses. That means that there are no symbols that separate terms. Therefore, even though we have 2 variables here, the x and the y, this is just one term. This will be a monomial. Okay. In our last examples, you can see here that there are 1, 2, 3 different symbols here that separate these terms. So we have 1, 2, 3, 4 terms. Therefore, we have a polynomial. So the number of additions and or subtractions will determine the number of terms that you have. Okay? Let's go to the top right-hand corner where you guys would have written down the word degree. And take a moment to copy down the definition of degree. The degree is just the sum, adding, of the exponents of the variables. Let me elaborate. Let's first tackle how to find the degree of a monomial. That is a one-term expression. Copy down these 3 expressions. In the first term, you have 4p to the 4th q to the 3rd. Now there are 2 variables there, and they each have their own exponent. If you want to find the degree of that monomial, you just add up those exponents. So this guy right here is a 7th degree monomial. In the second example, you see here we have 7cd. Now you'll remember that each one of the c and the d are going to have an exponent of 1. So since there are 2 variables, we add their exponents together. 1 plus 1, you will get a 2nd degree monomial. In our third example, we have just 3x to the 1st power. This is a 1st degree monomial. So in order to determine the degree of a monomial, you just add up the exponents of all the variables. Okay? Now let's talk about how we would find the degree of a polynomial. It's slightly different. Take a moment to copy down these 3 examples. You can see here on example number 1 that there is a plus that's separating those 2 terms. The 11x to the 7th and the 3x to the 3rd each have their own respective degrees. 11x to the 7th is a 7th degree. 3x to the 3rd is a 3rd degree. So the question is going to be, okay, well, there's 2 degrees. Which one is the degree of the polynomial? You just take the highest of all the different degrees. So we would say that this would be a 7th degree. And since there are 2 terms, it would be a 7th degree binomial. Go ahead and write down the full term. For number 2, there are 3 terms. And each one of the 3 terms has its own degree. So you can see here the first term, this guy, has a degree of 2 plus 1, or that's a 3rd degree. The middle term here has a degree of 4. And the last term has no variables. So it has a degree of 0. So 4, 3, and 0, well, 4 is the highest. This will be a 4th degree. And since it has 1, 2, 3 terms, a 4th degree trinomial. Last example. Notice we have plus here, minus, and a plus. That means we have 1, 2, 3, 4 terms here. Each one of the terms, let's see, the first term has 3 plus 2, it's a degree of 5. The second term, 2 plus 3, that's another degree of 5. The third term has a degree of 4. And the last term has no variable, so it has a degree of 0. So this question inevitably comes up in class. What happens if you have 2 terms that have the same degree? Well, you're just looking for the highest degree. So if there's a tie, that's fine. This will just be a 5th degree polynomial. Okay. Let's go to the bottom left part of your notes, the one that we wrote down standard form. Now take a moment to copy down this. There is a proper way to write these polynomials, and it is in standard form. And what that means is that you're always going to list your polynomial terms from greatest degree to least degree. Let me give you an example. Let's say we have this first example here. 6x minus 7x to the 5th plus 4x squared plus 9. Now what we can do is we can go ahead and classify this by the number of degree and the number of term. But in order to write it correctly, we have to rearrange it so that all the terms are from greatest degree to least degree. Okay, so of these 4, this one has a degree of 1, this one has a degree of 5, 2, and 0 respectively. So I'm going to rearrange them so that 5's in the front, then 2, then 1, then 0. Notice also that the sign in front of the term is telling you whether to add or subtract that term. So make sure it travels with it. So for instance, at 7x to the 5th, there's a minus in front. So I'm going to write negative 7x to the 5th. Then I go to plus 4x squared. And then notice that the 6x here has no term out in front of it. It's just considered a positive. So we add the 6x. And then lastly, add the 9. This guy is now written in correct standard form. And we can also go ahead and classify it as a 5th degree polynomial. This is now written in standard form with a leading coefficient, that is the first number of negative 7. Okay, let's do the next example. Let's say I have 4x squared minus x plus 9x to the 3rd. All right, well now I have 3 different terms because we have a subtraction and a plus that's separating those terms. The first term has a degree of 2. The second one has a degree of 1 because it's a little x to the first there. And the last one has a degree of 3. So to write this in the correct standard form, I'll write this as 3, 2, 1. 9x to the 3rd is positive. Then we've got a positive 4x squared. And then we've got a minus x. This is now in correct standard form. This is a 3rd degree trinomial. And it has a leading coefficient of 9. In other words, 9 is the first number when it's written in standard form. Okay, let's do a couple practice problems here. So bottom right-hand corner, on all these practice problems here, I want you guys to concentrate on a couple of things. 1, make sure that it's written in standard form. If it's not, then make sure that you do that. Next, you want to completely classify it by looking at its number of terms and its degree. Okay, so let's take the first example here. We're going to do 4 of these total. The first one is 4x to the third plus 3x. Okay, give it a shot. It's already written in standard form. There are 2 terms, and the first term has a degree of 3, and the second term has a degree of 1. So I'm going to leave it the way that it is. It's already written in standard form, but then I can classify it. I can say that this is a third degree, and with 2 terms, I'll call it a binomial. So next example. Okay. 2x plus 3x squared minus 1. Give it a shot. You can see that this polynomial expression has 3 different terms. The first term has a degree of 1. The second term has a degree of 2. And the last term has a degree of 0. So I'm going to rearrange this as 2, 1, 0. So 3x squared plus 2x minus 1. It's now written in standard form. And now I can also classify it. This will be a second degree trinomial. It will also have a leading coefficient of 3. Okay, next example. 3x. Go for it. Obviously, there's just one term here because there are no pluses or minuses. So it can't be rearranged, so it's already in standard form. It has a degree of 1, and it's also one term. So I would just label this as a first degree monomial. In other words, it has a degree of 1 and it only has one term. First degree monomial. And lastly, try this one. Last problem. All right, 4 different terms here. I've got a degree of 1, 4, 5, and 0. So I would rearrange this as 5, 4, 1, 0. Notice that the 2x and the 1 are both negative. They're being subtracted. Okay. It's now in correct standard form. There are 4 total terms, and the highest degree is 5, so I'll write this as a 5th degree polynomial. The leading coefficient of this polynomial is 4. Okay. Hopefully this helps you guys when you show up the next time in class. You should be able to classify these polynomials. Have a good one.